All right, welcome. If you're joining on YouTube, this is the Denver Erlang and Elixir meetup for Monday, August 4th, 2025. My name is Michael Lubis. I'm hosting tonight. The meetup tonight is sponsored by Praxeal.io, which is the first and only security platform with full Elixir support. If you're using Elixir or Phoenix in production, please check it out. Let me know what you think. I'd be happy to hear from you there. So for the main event, we have Holden, who is the current maintainer of Soblo, which is a really great security tool for Elixir developers. He works in security at Netflix, and the title of his talk is What's Next for Elixir Security. So I'm going to stop sharing my screen now, and we're going to go over to Holden.
Thanks, Michael, and thank you everybody for joining. Apologies for not doing my own introduction earlier before we started recording. I figured we'd just save it for now, but essentially, yeah, as Michael said, I'm gonna kind of talk about what's next for Elixir Security. And if you're thinking, "Oh my, that's a very generic title," it's because it was. It's very intentional. And but today, really, I want to be chatting about some upcoming uh, updates from the Sobolo side, from static analysis. I'd like to kind of continue where I left off from ElixirConf last year and talk about some areas that could be improved from in the Elixir ecosystem, and then additionally, kind of start to tease out some spicy Elixir use cases for offensive security. So, all right. So who am I? As Michael mentioned, I am currently the maintainer of Sobolo. I previously also contributed to SimGrep for supporting Elixir. I've presented a couple times at ElixirConf. You may have seen some of my talks. And I'm currently at Netflix as a security software engineer. Previously, I worked at Okta, but most notably, I worked at Podium for quite a while, which is where I got my first exposure into the Elixir ecosystem. So that was back in, oh goodness, 2019. So about 6 years now, I've been working in Elixir, which is crazy. So what are we going to talk about tonight? So we're going to do a kind of a brief stop into the state of static code analysis. Now it's a bit of a generalization. We're mainly going to be talking about Sobolo and SimGrep a little bit. And then we'll talk about Elixir's lack of defense for industry trends. That's the best section title I could come up with. And then we'll kind of do some forward looking. And then I'll leave some time for Q&A at the end. I will try and keep an eye on chat at the same time, but just know that we will have time at the end, or at least we should. So, all righty. So let's talk a little bit about static code analysis and where we're at with that for Elixir and support of it. So I'm realizing now that these dark slides are probably not the best choice for these logos, but essentially we have two solutions out there as of right now for security specific use cases. So we have Sobolo, which is represented by that logo on the left, which I'm actually not too sure where that came from. That predates me. I think Griffin probably made it. And then we have SimGrep, but both work kind of similarly under the hood, if you're ever curious. They both work by digesting abstract syntax trees and then sort of identifying statically patterns that are bad. So the benefit of Sobolo is it does it natively through Elixir code, because Elixir is great at metaprogramming and understanding itself. Whereas SimGrep uses a community standard called tree sitter to transform everything into a generic abstract syntax tree that's kind of the same across all languages, and then it applies its rules engine against that sort of generic pattern. That's why they can support so many different languages at once. So, Sobolo. I want to give kind of a brief history lesson because it impacts some things that's changed for Sobolo. So Griffin Byatt created originally. There's a really great ElixirConf talk where he sort of debuted it and some of the approach to it while he was working at NCC Group. Now, NCC Group was a company, a security consulting company that I interned for as well, and that's kind of how I was able to reach out to him and how I sort of got involved. And so we were operating out of their GitHub account for a long time. And it was just him and I maintaining it, and then mainly just me. But still, it was in the NCC Group GitHub account. And they recently unceremoniously changed their access policies, which is totally understandable. It's well within the right. But that suddenly meant that there was no more access for either of us to actually make and approve changes and things like that. And to be honest, I it'd been on my list for a while to fork it out, mainly because we couldn't apply best practices like I wanted to. I talk about it a little bit in one of my other talks at ElixirConf, but there's sort of this idea of using the GitHub CI to more securely use one-time access tokens to push out changes to like hex and stuff like that. And we couldn't do any of that because we didn't have, understandably, admin rights to the NCC group GitHub organization. So we couldn't actually follow our own or like my own advice. So I didn't love that. So it had been on my list forever, but that was kind of the solution was, hey, we're going to make a fork. But unfortunately, one of the byproducts of not having a heads up of this change is that I couldn't change the README to reflect that. And so I tried to leave as many comments as I could in various different spots. And I'm still monitoring that repo whenever new issues pop up. But generally, now that everyone's aware, don't go to the NCC group repo anymore. I made a fork and we have our own organization. It's a Sobolo organization, which has the source code. So there are some good news associated with this. So all throughout, we maintained access to Hex, Hex PM, which is awesome. And that essentially means that all of the historics, as far as like downloads and stuff like that, but more importantly, the sort of chain of updates when we release a new version isn't messed with. So that's very exciting. So you don't have to go and update, your mix files or anything like that. You will just inherit when you do another version bump. We always maintain access to that. So additionally, the fork, kind of the need to make the fork sort of kicked me in the butt to fold in some features that were pending and also do some other cleanup. So officially, the fork is more feature rich than the original repo, which is great. Again, if you just bump the version, I think we're on minor version 14 right now. If you just bump to that, then you'll be good to go and you'll inherit all of that. The bad news, like I kind of mentioned, can't make any further changes to the old repo. So I left a giant thing in all caps on the issues that says, don't go here, stay away. But we'll see. The code license for Sobolo should allow us to do this and stuff. We shouldn't run into any issues from NCC group in the future. I don't know any folks anymore from NCC group, so I'm having a hard time like reaching out. But so if anybody knows anybody, feel free to steer them my way. I did want to touch on SimGrep real quick. So SimGrep currently does have the existing Sobolo rule set, plus a couple extras that I haven't gotten around to like translating yet, that their processing engine makes a little bit easier to introduce the rules for. But those will come to Sobolo in the future pretty soon. Their taint analysis is a big feature that they highlight in their marketing campaign. I just want to say it's not yet working for Elixir. I would love for it to. I think it's on their roadmap, but because they are a SaaS driven product, they are a little bit more focused on customer needs, and so not a lot of customers are using Elixir at this time, but there are some, and I think it's growing. So I did chat with them when we released the functionality in SimGrep. So feel free to check that out. That's on YouTube, I think. If you want to learn more about the details and some of the strengths and weaknesses SimGrep has over Sobolo. I am not partial to one or the other. It's not a plug for the vendor. It's just I liked their general approach, and I always like supporting more tools that can help the Elixir ecosystem. So, all right. So I want to get into the meat and potatoes of tonight's talk. And this is, as I mentioned before, building off of my talk from ElixirConf last year, where I talk a lot about how to make Elixir the most secure language from default. And there's a slide I had at the end that was like, I want to talk about all this stuff. And so this is that stuff, or at least some of it, because as I came to find out, there was even more stuff that I wanted to talk about, and we didn't have time to get into tonight. So we're going to be getting into it. So I'm just going to start going through stuff because we're going to jump around quite a bit. Feel free to ask questions again or save it for the end. We're going to just kind of jump from topic to topic, but generally speaking, this is how the Elixir ecosystem could stand to be improved from a security perspective. So I don't know how many of you have heard about policy as code, but it refers to sort of defining and enforcing security or compliance rules through code. So similar to infrastructure as code like Terraform. Specifically, there's tools. There's a lot of different tools out there. So I'm not suggesting you just use Pulumi, but I like them and I like the ideas behind it. So like tools like Pulumi and specifically their crossguard allows for writing such rules in popular languages, so like Python, TypeScript, Go, and stuff. But Elixir lacks that sort of first-class support in this area, which I think is not terribly surprising for anybody who's tried to build against commercial SDKs. You know, hey, where's the Elixir SDK? Well, there's a community one, right? And you know, the Elixir community can still leverage external policy engines. So there's things like OPA, Open Policy Agent. It uses its own Regio language, but using this adds complexity. You know, there was some discussion on the Elixir forums from a team that actually integrated OPA by writing custom plugs to evaluate policies, and it worked. But you know, that does require learning a new policy language, and maybe it isn't as seamless as it could be if we had an in-language solution, especially with Elixir's strengths at handling, you know, DSLs. It's something that I feel like is pretty ripe for innovation. Other ecosystems like Python, you know, they have policy libraries. They allow policy as code within the application stack, whereas we have to bolt it on. And yeah, this is definitely an area for ecosystem growth, whether it's libraries to express authorization rules or cloud-based guardrails. You know, then until then, adopting policy as code often means using external services or writing custom integrations. So, Elixir fuzzing. I think fuzzing is really interesting. So, fuzz testing, is the process of feeding sort of random or malformed inputs into software to find bugs or security issues. Many languages have pretty modern fuzzers. In fact, there's a company called Trail of Bits. They're a security focused company. They built an open source tool called Ruzzy because the Ruby community sort of lacked a high quality fuzzing tool, and they wanted to fill that gap. And that was actually like, I saw that tool and that's what made me go, hey, like, why don't we have that for Elixir? You know, we don't have like an equivalent coverage guided fuzzer. And that's sort of their approach is hooking on to test coverage and injecting inputs via test coverage into marrying it with a fuzzing engine, which is pretty neat. And the current state of the art for Elixir is sort of property-based testing, using things like prop check, which is itself a wrapper for proper for Erlang. You know, it can serve a similar purpose, but it's kind of not the same as full fuzz testing. So it means that Elixir projects may be missing out on, you know, more automated bug finding power that fuzzers and other ecosystems provide. We can take inspiration from Ruzzy's approach. You know, we could either create our own native version or create wrappers, or you know, I've even started to explore hooking into like coveralls and X coverage and stuff like that to just be able to create middleware for that. But as of now, adding fuzz testing or doing that as requires custom effort, whether from an individual or a team having to support that. All right, types, which is the spicy topic in the Elixir community, I feel. As many of you know, Elixir is moving towards more static typing, and this opens the door to new safety techniques that are, you know, present in other typed languages. And one of these ideas is through trusted types, essentially using the type system to distinguish trusted safe data from untrusted data. In web development, for instance, the Trusted Types API prevents DOM-based XSS by ensuring only sanitized, you know, trusted HTML objects can be inserted into the DOM. Now, security experts often recommend that if you're using a language with a type system, capturing whether that data is tainted or untainted in the type system is a good thing, and make the compiler tell you that you're assigning tainted data into a context that expects untainted data. There's a lot of tainted, but basically imagine having like an HTML safe string type in Elixir, right? It's just like in object oriented, it would just be like its own object, right? But hey, we don't talk about objects in Elixir. But functions that would, we can imagine functions that produce output for HTML templates could be required to return those HTML safe strings. And then you could only get one by explicitly escaping or sanitizing a regular string. So until it goes through that function, then we don't trust it, and it would be marked in the compiler. So the compiler would then error if you try and inject a plain untrusted string where a safe type is expected. So Phoenix already does something at the runtime. It's kind of like this with like the Phoenix HTML safe protocol to prevent raw user input from being rendered unless explicitly marked safe. But a static type system could take this further by catching mistakes at compile time. So another example, user input could be typed as tainted string and only converted to safe string after passing through the sanitizer function. And so as sort of Elixir's type system evolves, we could explore the idea of introducing trusted types as part of the language itself instead of having to leave it as an exercise up to the user itself to implement, to abstract away, right? So yeah, the goal obviously would be to have the compiler enforce that and clean before use. So providing another layer of defense in depth. Let's see, Dan says there was Codebeam talk about fuzz testing. Maybe it was Elixir. I do recall that. If I recall, I want to say that it definitely gave me a lot of inspiration. I think that was the last year. And
it was really interesting.
Yes, no, 100%. And I think it was mainly focused on like the usability fuzz testing or like finding memory dumps, which is in the same realm of security applications too, right? But I think at the very least, like taking those ideas and expanding upon it and creating like an actual testing, like a fuzzing harness for Elixir is definitely missing.
Yeah, it was clearly like his sort of research work, but
yeah,
it at least it had the ingredients that you're talking about.
Yeah, no, absolutely.
Yeah, it was actually an awesome talk. I was like, wow, that's the things that he found were pretty amazing.
Yeah, no, it was super
neat. Which I think makes the case that it's really interesting technique.
Yeah, and a lot of room for development. I actually like, I don't know how much I can say, but I've been working on some fuzzing stuff, and it's real crazy stuff out there. But cool. So, I mean, actually, in a very similar vein, DOS testing or DDoS testing, however you want to split it, is something that also is kind of ripe for innovation within the Elixir ecosystem. So, the Beam is famed for its ability to handle thousands of processes and maintain its high availability. And this gives some implicit resilience against certain types of denial of service attacks. It's hard to overwhelm a well-tuned Phoenix server with just pure volume of requests compared to traditional threaded servers. But the Elixir ecosystem currently has no specialized DOS testing toolkit tailored to its unique challenges. Now, other communities sometimes have tools to simulate specific attacks. So, for example, in the web world, we have Slow Loris or sort of regex performance testers. With Elixir, most developers rely on only general load testing tools. I think the most notable one I think is Sung, Tsung, which is actually written in Erlang to gauge performance under load, but additionally on careful code review for DOS vectors. But that's just load. That doesn't necessarily take into account how things interact or the specific Elixir specific pitfalls. So most notably atom exhaustion, but also other things that we can benefit from. So like a good example, well, if you have certain operations obviously that are expensive, and this is true beyond just Elixir, right? Like that could be a vector for DOS attacks. But I think in Elixir we have this incredible opportunity to be able to hook in basically wherever and monitor from all these different points very natively. And so I think we're really lacking that sort of toolkit to be able to come at it from that angle, if that makes sense, where we have such direct access to processes and through testing, test coverage and stuff like that. We just have so many good. I don't know what the word I'm looking for is best practices just from the community itself that we can take advantage of to really get eyes on. Because a lot of the open source DDoS tools that I've used in the security industry are just, they don't care what stack you're hitting, right? They're just like, oh, web endpoint, I'm just going to hammer it. And we have this opportunity to really get into that sort of middle ground. And instead of having just a generic dynamic application security tool, you have like they call it IAST, which is interactive application security testing, where you have kind of a mixture of both. I have access to the code, but I also have access to the running web service that I can hit and send requests to. So I think we're really kind of missing that. I've gotten really far off my talking points, so I'll return to that. But generally we rely on guidelines and static analysis to catch DOS vulnerabilities. Soblo will actually flag some of those issues, but it has some limitations, right? Like if Soblo's it's very core, doesn't stress test your app's performance, right? It just looks for patterns, and if a pattern gets obfuscated or whatnot, then it might not reliably find it. And so as of today, to test DOS resilience in Elixir, one has to combine load testing and code auditing for the patterns that we've talked about. And if you have critical functions, you should consider writing property tests that feed in large or pathological inputs to measure if they degrade gracefully. And you could also consider deployment level defenses, using web application firewalls or like rate limiting, things like that. But like that just again points to the fact that, hey, if we have this need to protect ourselves at a different layer, then like it means we're missing it from the application stack. Now, I know like it's really hard with DDoS itself, because being able to rapidly spin up environments to support that kind of load is not only costly, but very hard. And it's a multi-million-dollar problem that Cloudflare and AWS make a lot of money from. But I will say that, like, what is Elixir good at, right? It's like highly distributed workloads and stuff. So having some sort of spiking framework to handle, at least mitigate some amount of DDoSing would be kind of interesting, to say the least. Cool. So the last sort of insecurity I want to talk a little bit about is the Beam decompilation. Now, many developers assume that compiling code, especially compiling it down to bytecode, provides a layer of protection or obscurity. And in Elixir and Erlang's case, it's not really true. And it's actually pretty easy to reverse engineer Beam files back into their source code, or to clone it, essentially. Or I guess at least get something resembling the source code, if it's not the exact variable names and such. The Beam bytecode contains a wealth of information about your program, function names, atoms, module structure, and even debug info or abstract syntax trees if they haven't been stripped. And there's tools already that exist to leverage this, right? The Erlang VM itself can provide an abstract code chunk, and it returns, a form of the AST for the module, which can then be pre-printed. And community tools like Beamfile and Beam to Elixir have been created to sort of output Elixir source code from a Beam file. But, again, those require the debug info to be included. But there has been, I want to say it's 2014, there was some academic research done on reconstituting source code exclusively for Erlang, but like this would work for Elixir without the debug info flag being provided. So anyways, it basically just like, what does this mean? And it just means that secrets or intellectual property embedded in Beam files are not to be considered safe. So if you embed credentials or license keys in your code, an attacker with the Beam file could theoretically read them out. And if you're thinking about distributing only compiled Beam files to hide source logic. Just know that a motivated person could decompile them and understand how your application works, even without a perfect decompiler. Someone could use some of these tools to get low-level instructions and sort of analyze it. As somebody once noted, going from Beam to exact Elixir AST is almost impossible in full generality due to lost metadata. Macros are expanded and variable names may be different, but recovering a functionally equivalent version of the code is very achievable, especially if the debug info is present. For security, this sort of reinforces a classic lesson. Don't rely on security through obscurity. And if you have proprietary algorithms and you ship them in Beam form, assume they can be read. And if you have to distribute code, but you want to protect it, consider licensing and legal agreements, because technical barriers can be minimal. There are obviously some obfuscation strategies available, but the Beam isn't necessarily designed with obfuscation in mind. Now, this brings up an interesting side effect. It also means that security defenders, or like security practitioners, can more easily analyze malware or malicious dependencies that are written in Elixir, but there's a counterpoint to that, which we'll talk about here in a little bit. As Elixir gets more adoption, we might see more user-friendly decompilers or IDE plugins or plugins for other decompilers that are used in the community, like Ydra or Hexrays and stuff like that, to inspect Beam files. So in summary, treat compiled Beam files as only slightly harder to read than your source code. And when doing security review, you can actually leverage this to your advantage. So for example, you can inspect third-party Beam files from hex packages to ensure that they don't contain hidden backdoors, since you can just decompile them. But conversely, don't assume that your secrets or logic are hidden just because you compiled your code. All right, so the year is 20 something. And we live in a future where the Elixir ecosystem is secure by default to build with. New projects get deployed with, out of the box, full SOC 2 Type 2 security compliance, and all the things that I said were insecure have been fixed. It's performance, it's high availability, the ease of use and notoriety has risen so much so that Elixir is becoming commonplace in the industry. But more users of the language means an increase in bad actors. So what evil could Elixir be used for? Now, the things that make Elixir, personally, a joy to use and a solution to many technical hurdles are also what make it an attractive environment for attackers to use to cause mayhem. Livebook is so feature rich and provides an easy playground to run automated playbooks and host malicious code. Elixir has an intuitive API for generating high performance and vastly distributed services for things like DDoSing, for web scraping, or vulnerability scanning. The list goes on. I kind of alluded to this before, but since Elixir has the ability to metaprogram, it's not that difficult to imagine that an Elixir-based piece of malware that's loaded onto a target system, right, with the simple base instruction set of run whatever my command and control server tells me to run, it'll receive the command and then use, code evals to execute them and, have its way with the service and stuff like that. But then when defenders come to clean up the mess and do their, they sandbox the environment and they take it apart and they're like, all right, what happened? Figure out how big of a risk we're at, and they take it apart and they find out, oh, all it did was just run code, right? It doesn't have the telltale tracers of what it did or where it communicated with. It's clean. So it's just a blank slate. So food for thought. There's a lot more where one could take this sort of line of thinking of applying offensive techniques to the Elixir ecosystem. So maybe stay tuned for some more explorations from me, because I have a lot that I'd like to explore in this regard. So with that, I want to say thank you, and thank you to Paraxial and Michael for hosting this and inviting me to chat. And you can find me at any of these places. And if you're coming to DEF CON 33 later this week, hit me up and we can chat. So leave time for questions.